Good morning, everyone. This is Mike King from Esri. I am the Global Manager for Public Safety in the emergency call taking and dispatch industry. I also oversee our efforts with FirstNet. We have participants joining from across the world today. We appreciate all of you for taking time, and of course, many more will hear the proceedings via the recording in the coming days. I'm supported today by my colleague at Esri, Ray Umali, who's a marketing coordinator here. He will participate from time to time throughout the webinar, and I appreciate his help. Our presentation today is really timely, given recent announcements by Apple and Uber and others on how device location can be consumed and analyzed, even on the Esri platform, has given us pause to reach out to a couple of companies that we enjoy working with, and we've invited them to speak today. I'm pleased to welcome our two presenters, Mr. Reinhard Eckel and Carl Larson. Carl is a senior product manager with responsibility over tactical mapping at GeoComm, one of our partners. He is a geography major from St. Cloud University, and he has more than a decade of experience in building out complex GIS solutions for 911. We'll hear from Carl after Reinhard, but let me introduce Reinhard Eckel, who is the Vice President of Product and Public Safety at RapidSOS. I've known Reinhard for a number of years. He's has an MBA from Stanford's graduate school. He's a voluntary paramedic, which I really appreciate, Reinhard, and I can't move forward without noting he's a native Austrian and someone who I've enjoyed speaking about wonderful things in Europe about. Thanks to you both for your preparation and for today's presentation. With this short introduction, we'll turn the time over to Reinhard, who will outline the remainder of the webinar, and then I may speak to you for a moment at the conclusion. Thanks again, fellas.
Thank you very much for the introduction and hosting this webinar today, Mike. It's always a pleasure working with you and Esri. As you said, it's a very timely occasion to talk about location accuracy in the context of 911 calls. There's been some recent announcements, and I will unpack those for all of you. And I want to thank everybody for taking time out of your busy day to joining Esri, GeoComm, and RapidSOS in our webinar. What we'll be talking about today is I'll start with explaining the location challenge in 911 and the technology that sits behind 911 location and how new technology is becoming available on smartphones. I'll talk about our solution, the next generation 911 Clearinghouse, which is a location information server that provides faster and more accurate location. And then Carl will be talking about the joint solutions that GeoComm and Esri have built and deployed for accessing the clearinghouse information and displaying it in the 911 public safety answering point. And then at the end of the presentation, we'll have ample of time for questions and answers, and looking forward to a lively discussion of any topic that comes to mind. So we'll start with the location challenge, and you know, really this is how every 911 call starts. You know, 911, what's the location of your emergency, or 911, what's the address of your emergency? It's usually the first sentence that a caller hears when you know, they make a request for emergency assistance, and this happens many times a day. So we have 240 million 911 calls going into approximately 6,300 different 911 communication centers, operating on 25,000 different systems with a variety of components that you know sit on the infrastructure behind it. And many people have been asking, why can Uber find me but 911 can't? Why is it that you know the 911 location technology that's available to public safety answering points is not as you know fast, accurate, and reliable as the technology that we all use in our smartphones for commercial purposes? And that's not a hypothetical question that has real life consequences. And 911 has been in the news a lot over the past years, and not always for the right reasons, right? So there's a lot of stories here in the news around how the 911 system is facing severe challenges and how it's not meeting the citizens' expectations. And today I want to talk to you about how we can address that, and how Esri, GeoComm, RapidSOS, and other technology companies are cooperating in a industry approach to enhance the 911 location that's made available to dispatchers and call takers. But before we go into the solutions, we want to first quantify the problem. So Ray, if I may hand over to you for the first audience poll.
Yes, Reinhard. So to help us quantify and understand the mobile challenges, what % of 911 and emergency calls are from mobile phones? Tell us what you think. Is it less than 50%? Do you think it's around 50 to 60%? Or in the 70 and 80% range? Or maybe you think it's greater than 80%? I'll give you a couple more seconds to think this through and tell us your opinion. And Reinhard, it looks like the majority of our audience, almost 52%, think it's greater than 80%. And of course, it depends on the demographic and region. It could be anywhere from 60 to 90%. So over back to you, Reinhard.
Thank you very much, Ray. So those are some impressive numbers, and it's interesting how quickly they shift. If we had done this poll 3 years ago, the answer might have been 60 or 70, and the numbers that the National Emergency Number Association, NENA, published a few years ago suggested that we're closer to 70%. And now, there's a lot of people who are saying it's 80% or higher, and that creates a real challenge because in a landline call, the address or the location of the caller is very much known at the very beginning of the call, and it's very reliable. For wireless calls that come from a mobile environment, which now could be 80% or more of calls, it's not always that easy. And a lot of people are asking, why is that? So when somebody dials 911, the location that's being made available to the public safety answering point initially when the call is delivered is very often only the cell tower address or the cell tower sector description of the location, which could be a really large circle of uncertainty, or just a general search area that could be miles. That's usually referred to as phase 1 location, just cell tower address. That's obviously not sufficient, and the wireless industry has implemented a lot of improvements to provide what's called a phase 2 location, which in some cases is cell tower triangulation, using a variety of different towers to approximate a location based. It could be a GPS location, which is the network accessing the GPS chip on the phone and trying to retrieve a location from the phone. That can be highly accurate and reliable, but really only in outdoor scenarios. And that was fine maybe 20 years ago when people only used mobile phones outdoors. But given that most people don't have landlines anymore, now we see a high percentage of wireless calls coming from indoors, where GPS is really not appropriate because it often fails and then falls back to cell tower triangulation, or even worse, just the phase 1 cell tower address or sector. At the same time, the device capabilities have evolved greatly over the last few years. And companies like Apple and Google and Uber famously use more advanced location services that use a fusion or hybridization of different sensors. So in addition to cell tower radio signals and GPS, they also use Wi-Fi access points. And there's a large number of Wi-Fi access points that our devices can see at any given time. We don't necessarily have to be connected to the Wi-Fi access point to use it for positioning. We just need to have awareness of its proximity and the signal strength. And then there's huge databases sitting behind Google and Apple that do calculation with a large number of data sets, data points, to approximate and estimate a position based on Wi-Fi access points. So many of you will have seen a screen similar to this, where you can see multiple Wi-Fi access points in range. And given the hundreds and thousands of phones that walk in and out of coverage over a Wi-Fi access point every day, and given the large number of Wi-Fi access points that every phone touches every day, all of that gets reported back and statistically calculated so that you can enrich a hybrid position that is very accurate indoors as well. Add to that Bluetooth beacons, barometric pressure sensors, gyrometers, accelerometers, step counters, and what you get is a really accurate and reliable picture on where the caller or where the user might be located. So the location technology on the smartphone operating systems has improved so much, and the citizens expect 911 to be able to access that location in a fast, reliable, and secure manner. So how do we get there? How do we make sure that 911 centers can access those device location services that come directly from the device instead of being calculated on the network? That's what I'll talk about, and Carl will touch upon that. But first, we want to talk a little bit about the requirements for location accuracy coming from the Federal Communications Commission, the FCC. What we'll see is that the requirements that are in place for 2018, only 50% of calls need to be within 50 meters of ground truth. For 2021, 80%, meaning 4 out of 5 calls, need to be within 50 meters of ground truth. And 50 meters equates to around 150 feet. So it's still a sizable radius. But what we see in results coming out of the test beds that the CTIA has established and that we as a vendor have entered together with one of our smartphone operating system partners is we see that almost a year ago, in the fall of 2017, our test data showed that we could already meet 90% and more within 50 meters. So we're really not talking about a hypothetical solution. We're talking about something that is available today. The phones are capable of calculating position much better than they are required to do, and we just need to make sure that they get the location to where it needs to be, which is the call taker or dispatcher who answers the call and needs to know the location as soon as possible so that they can dispatch responders and save lives, which ultimately is what we want to achieve. So how does that work? How do we get the location from the device into that next generation 911 clearinghouse that I'll talk about? How does that transfer of information work when somebody calls 911? And how is it different from what's being done today with the ALI database and phase 1 and phase 2 and all of these terms that many dispatchers are familiar with? So I'll start with a basic description of what is the NG911 clearinghouse. And NG911, as many of you know, stands for Next Generation 911, which is an IP-based paradigm that is the backbone of a new infrastructure for 911 that is more modern and can accommodate all sorts of data types. In the framework of NG911, the clearinghouse is a location information server and an additional data repository. And it's built to meet the NENA I3 standards and also other industry standards like the IETF RFCs for listen ADR, and is really being developed to be supportive of the next generation 911 transition and trying to promote the benefits of NG911. In other words, what does it mean to be a listen and ADR? It means you receive information from devices, and that could be smartphones or cars or wearables or applications, could be anything, and then makes it available to public safety in a standards compliant fashion. So it's very important to understand that the clearinghouse supports industry standards and makes it possible for public safety to get all the information they need using one standard interface. instead of having to build new interfaces for every new data source. So connected devices like smartphones send data to the clearinghouse, and the clearinghouse makes it available to public safety, so that public safety doesn't need to interconnect with every device individually. Now, how does the data travel from the phone that makes a 911 call all the way to where it's ultimately made available through GeoComm and Esri technology inside of the public safety answering point? So let's say somebody dialed 911. As I mentioned earlier, the first information that is known is which cell tower is it hitting initially. That cell tower information is being used to route the call using either selective routing or the next generation equivalent of that. But with the information about the cell sector, the call is being delivered to the 911 center or public safety answering point. At the same time as the call is delivered, the 911 center also gets a phase 1 location information, which typically is only the cell tower address or a cell sector directional. That's obviously not good enough in many cases. It's too broad of a search radius. So what can a 911 center do to request location information? They can make what's called a rebid, requesting a phase 2 information from their location database, the ALI database, which then in turn steers towards a third-party ALI database managed by the carriers or their service providers that request information from a positioning center. And the positioning center, again, hosted by the carriers or their service providers, tries to get a phone location from the device using GPS, using standards called 3GPP. There's definitions in there. It's all very complex. Or if that fails, request network location using different mechanisms that estimate a position based on different network metrics. Once that calculation is completed, the location as a phase 2 fix will be returned to the 911 center. All of that process takes usually 25 to 30 seconds, and while that chart might look complicated to you, it's actually highly simplified. There's a lot more complexity behind that chart, and some of these infrastructure components were built in the 1980s and haven't been modified much since. So even when the device gets a good location from the phone, it still does not make it to the 911 center in a timely and reliable fashion. And that's going to be incredibly important to know for the future is, some carriers are starting to implement or have implemented device-based hybrid location services on the smartphones, but because of the complexity of the system and because of the delays that are built in due to the fragmentation of databases and the complexity of the legacy system, very often that location does not make it to the 911 center when it needs to be there. Even if it's available, it often is available too late, and it's just not reliable. All of our testing has shown that it's really difficult to address the location challenge through a system that was built in the 80s for landlines. It's just not what we would design in 2018. So if you look at all of that, we don't interfere with it. The location is still being calculated by the wireless carrier and delivered through the ALI database like it has been for the past years. But in addition to that, the device also sends the location through a robust and secure IP pathway to the next generation 911 clearinghouse. And that is functionality that is managed by the device's operating system, whether that's iOS or Android, or whether that's on an application that's installed on the phone, doesn't matter. When somebody dials 911, the location is being sent to the clearinghouse. And it's being initiated from the device, which means it's much faster, it uses much more modern transport mechanisms, and it can be predictably and reliably transmitted. Now, what happens when it sits in the next generation 911 clearinghouse? The 911 center, when it receives the call, automatically makes a query to the clearinghouse and requests information about a certain call. And we're using next generation 911 data formats for that. So basically, the software that's installed in the 911 center says to the clearinghouse in an automated handshake, I have this call, do you have location for it? And it's using health and PIDOFlow and all the NINA I3 elements for location information server data transmission, and everything's encrypted end to end, and everything's using IP mechanisms in the spirit of NG911. So how does that work? Obviously, you need to have software installed or available to you in the 911 center that makes the request out to the clearinghouse and then displays the location on a tactical mapping application. And Carl will talk about that in the next chapter. But obviously, a lot of you will be asking yourselves, where does the location come from? Why does the phone know to send the location to the next generation 911 clearinghouse? How is it that the location can be sent without installing an app, just as part of the operating system? So here's where I come back to the announcement and the timeliness of this webinar that Mike has mentioned in the introduction. So there's going to be about 3 topics that I'll talk about. The first one is Apple. Back in June of this year, Apple has announced that they are working with RapidSOS to implement a supplemental location solution, which allows data from iOS 12 devices, iPhones that have been upgraded to iOS 12, that location from these devices will be shared in a reliable, secure, and fast fashion to make it available to public safety. And back in June, we announced that at the MENA conference in Nashville, and it really sent a big wave through the 911 community that relief is on the horizon for a problem that needed to be solved very quickly. And this week I'm very happy to announce that on Monday iOS 12 was released publicly, and location data for users that have done the upgrade to iOS 12 is already flowing and is already being received by 911 centers using this technology. Apple is an incredibly important technology company that has a lot of great work, has done a lot of great work in the space. But there's also devices out there that don't use Apple's technology. So the other part of the smartphone ecosystem is Android, the operating system by Google that is used on almost every other smartphone device other than Apple. We have done a pilot project earlier this year to demonstrate that the NG911 Clearinghouse can use the Android emergency location service to convey the device location securely and fast to the 911 centers using the clearinghouse. And many of you have been asking when this will be available in a more widespread fashion than just a pilot. So speaking of timely, this morning, about 3 hours ago, Google and RapidSOS have announced that we now provide emergency location for 911 centers nationwide. The rollout has already started and will continue over the next few weeks. But every 911 center nationwide that uses the next generation 911 clearinghouse will be able to receive locations from the Android emergency location service, which is installed on every Android phone with version 4 or higher. And users do not need to do an upgrade. They can just automatically call 911 like they have before, and their location will be sent as supplemental data. And if you would like more information about this announcement, you can visit our blog and find out more. Back to the pilot, just a few findings that were published earlier this year. The emergency location service from Android was more accurate and faster than the traditional E911 location. We found that PSAPs successfully received that location as supplemental data in addition to the alley information, not replacing it, and it was integrated into their existing software. And Carl will talk more about what that means. But in all of that, we should never forget that this is not just technology for technology's sake. It's technology that is built to save lives by improving the emergency response to life-threatening emergency calls, whether that's medical calls like the ones I've experienced when I was working in emergency medical services, or whether that's law enforcement emergencies that law enforcement officials like Mike King used to be experienced in their career, or whether that's fire emergencies. Location matters, and what we saw in the pilot is that faster and more accurate location actually makes a difference in emergencies. Now, the last announcement that was made earlier this year that I want to walk you through is with a technology company called Uber that provides ride-sharing services across the nation. For them, they also want to provide a better safety experience for their users and passengers and drivers. So they have announced that they have built a 911 assistance feature that makes accurate device location available to 911 through the clearinghouse, and also shares additional data around the trip that can increase the situational awareness around the incident. So that's where the data is coming from. Apple, Google, Uber, really this is deployed on the majority of smartphones and will make a real difference in how 911 callers handle location data for emergencies. And really excited to talk more about what that means for public safety, how PSAPs and 911 agencies can start receiving the data, and how GeoComm and Esri have worked together to provide a solution to public safety that really makes it a lot easier to handle emergency calls. So with that, I would like to hand it over to Carl Larson, Senior Product Manager for Tactical Mapping at GeoComm.
Thank you, Reinhard. That's extremely exciting news this week with all the developments. So I'd love to dive in deeper and see how this applies in 911 and CAD dispatch mapping applications. So a little about GeoComm, so you know who we are. We are a 911 GIS company, and we are based in St. Cloud, Minnesota, but we have 911 and PSAP customers from coast to coast across the United States. We've been in business for 23 years, and we are laser focused on GIS for 911. We are an Esri Platinum Tier business partner, so all of our technology and capabilities are based on the Esri ArcGIS platform technology. In many ways, GeoComm apps and services extend the ArcGIS platform into a complete location mapping solution for 911 and CAD. So while we do not make 911 or sell 911 telephone systems or computer-aided dispatch or CAD systems, we do build the maps and apps that can be integrated and embedded into those systems and solutions. So at GeoComm, we have three main lines of business. Those are tactical mapping, which I lead, 911 and CAD GIS data management applications and services, and third, our next generation 911 core services, which focuses on emergency call routing based on the location of the caller. But enough about GeoComm. Let's talk about device-based hybrid location in 911 PSAPs. First, how does 911 PSAP mapping work? The pictures displayed here show a typical map that would sit in front of a call taker at a 911 center when they're receiving a 911 call. So a call taker will answer a 911 call, and the map will automatically zoom and show an icon where the caller is located according to the 911 system. So these screenshots show two different applications that are GeoComm mapping applications. The one on the left is a ArcGIS engine-based application that's deployed locally on a workstation. And on the right, you have a web-based application using Esri's ArcGIS Enterprise technology. And each of them will map real-time 911 calls to show the call taker or dispatcher where that caller is coming from. GeoComm uses various Esri SDKs and APIs to build complete, packaged, purpose-built 911 mapping applications that can either be standalone or hosted. Getting a little bit into the details of how it works, as Reinhard was saying, in a PSAP, when a 911 call is received, you will get automatic location information, or ALI, delivered to the mapping system. That ALI information is 512 characters of ASCII text that contains the phone number, the location of the caller, the subscriber name, class of service, and so on. So the mapping system will then parse out the location from that information, which is either a street address or a latitude, longitude, and then place an icon on the map to show that. So getting into wireless calls specifically, and as Reinhard mentioned, those estimates are 80% or more of all calls today. The best case scenario is what we see pictured here on the map. But there are challenges today that need to be addressed. And as Reinhard mentioned in those location accuracy standards and tests, we do see 3 common problems with wireless 911 calls today. Number 1, we typically don't get a latitude longitude location for a 911 call until 25 or 30 seconds or longer into the call. Instead, you will get what's called a phase 1, which is the location of the cell tower or sector that transmitted the call, and that can be many miles off. Number 2, in some cases, this is not automatic, and it requires the call taker to manually do a rebid, which reaches out to obtain that location, which can take a few seconds in itself. And finally, number 3, in many cases, the accuracy is not that good. This is especially the case when the caller is indoors where GPS does not work well, such as in large office buildings, schools, hospitals, government buildings, and so on. And finally, to point out, the US EPA estimates that the average US citizen spends 80% or more of their lives indoors. So you can start to see how this is a big problem. In order to solve this, in 2015, the FCC imposed new rules on the nation's wireless carriers to improve wireless location accuracy, which is what Reinhard was describing earlier. And for the first time, these rules required the carriers to be able to locate mobile phones indoors at the same location accuracy and eventually include elevation data as well. These standards include a multi-year period for building and rolling out this technology so that they can accomplish the accuracy standards provided. But at the same time, RapidSOS devised a solution to obtain device-based hybrid location for live 911 calls through the RapidSOS Clearinghouse. And as Reinhard stated, this is a pretty big deal and totally unprecedented in the world of 911. And on top of all that, they've decided to make it free for all 911 PSAPs in the US. Early on, GeoComm partnered with RapidSOS to enable 911 mapping applications to retrieve device-based hybrid location through the RapidSOS Clearinghouse. And I wanted to share some of the results here on the screen. Our first pilot was in the city of Frisco, Texas, which is a Dallas suburb in the NCTCOG region. There, while on site, we deployed new mapping technology using the ArcGIS Runtime 100 SDK onto call taker positions. We then provisioned indoor GIS maps of government buildings onto the GeoComm map. These indoor GIS layers were created by the city GIS department using Esri ArcGIS tools. Then we sent out test callers with Google Android phones to go out to the government buildings that we had indoor GIS for and walk around and place calls into the 911 system. When those calls arrived at the 911 PSAP, the GeoComm Esri map would go and reach out to the RapidSOS Clearinghouse to obtain device-based hybrid location and then place that on the map. The results for the pilot showed a stunning increase in location accuracy when indoors. For the first time ever, call takers could see a 911 call location from a mobile phone inside of a building on top of an indoor map showing what room the caller was in, or if they were to the left or right of a staircase. If you have some time, I would recommend you go to YouTube to see the video of the pilot testing and the 911 dispatcher reactions to that pilot test. Just type in RapidSOS GeoComm Indoor 911 to find that video. This slide shows another example. In this case, we enhanced our web-based mapping application for 911 that is powered by ArcGIS Enterprise to query the RapidSOS Clearinghouse for device-based hybrid location when we received a wireless 911 call. The application maps both E911 reported wireless locations and the device-based hybrid location from the RapidSOS Clearinghouse. This case, we were in Washington County, Minnesota, which is one of the Minneapolis-St. Paul metro area 911 PSAPs. So what we did in this case was we literally stood right next to a 911 call taker, pulled out a mobile phone, and dialed 911 to see where the call would map in the E911 system. That system initially put the call on the other side of the river in the state of Wisconsin. But after a few rebids and over 30 seconds later into the call, eventually the best location we got is shown right here on this screenshot by the red phone icon with the blue shaded confidence area of that location. Now, where we were actually standing was in the law enforcement center, which is represented by that building footprint, and the blue dot is a device-based hybrid location that came in from the RapidSOS Clearinghouse for that very same call. And that's actually pretty much exactly where we were standing when we dialed and we made that call. As you can see, this is quite a difference. Imagine if you were working in the law enforcement center in a room by yourself and you had a medical issue or you were assaulted. With no one else around, you pulled out your mobile phone and dialed 911 for help. But you could not verbally communicate where you were. The best E911 location puts you across the road in a residential neighborhood. That's a lot of doors to knock on or break down for emergency responders, and they still wouldn't find you. As a result of this, GeoComm is pleased to announce that we have made the business decision to add support and automatic query of the RapidSOS Clearinghouse for device-based hybrid locations to GeoComm ArcGIS 911 mapping applications for no cost to our customers. We have added this support to our web-based 911 mapping application GeoLink server, as well as in our new Windows desktop 911 and CAD mapping application called Dispatch Map, which uses the Esri ArcGIS Runtime 100 SDK. Dispatch Map is also white labeled and sold by our partner Motorola Solutions as Vesta Map Local. But beyond this, we wanted to highlight a very important and real issue for 911 PSAPs and authoritative GIS data organizations. Those are the entities that build and maintain GIS maps that go into 911 call taking and CAD dispatch mapping applications. The FCC only regulates wireless carriers and not 911 PSAPs or GIS entities. When the FCC put these rules into place, they were doing what they could to make 911 wireless location work better. But FCC leadership was quick to point out that a PSAP or emergency responders, for them to actually do anything with an indoor location or a latitude longitude with elevation, a new kind of map is needed in the PSAP. These are maps depicting building footprints and indoor details such as floors and rooms. With that said, we have a poll question related to where you are at with your indoor GIS. Take it away, Ray.
Thank you, Carl. And our second question is, does your agency currently deploy indoor GIS into your public safety apps? Are you just getting started and gathering some information? Are you further along and are now in the planning stages with indoor GIS? Maybe you are an early implementer and have started to create and deploy indoor GIS layers. And if you are even more early in the implementation stage, maybe you have building footprints with indoor GIS already in production. So tell us where you are in this process. We'll give you a few more seconds to let us know. Carl, it looks like a majority of our audience today is just getting started with this process, is in the information gathering stage of building their indoor GIS into their public safety apps. Can you tell us more about how we can start building high-level 2D and 3D indoor GIS to support public safety users?
Certainly, thank you, Ray. Yeah, so that's exactly where the next slide is going. So GeoComm's advice to 911 PSAPs, authoritative GIS entities, is to do exactly that. Start building high level of detail 2D and 3D indoor GIS to support your public safety users that can benefit from the hundreds of millions of mobile phones that will be sending device-based hybrid locations to 911 via RapidSOS. Also be aware of these changes and modernizations in the nation's 911 system and support this through the mission of GIS. Take a look at and follow existing, new, and upcoming Esri technology, such as ArcGIS indoors, that makes it possible to do things like point-to-point navigation inside and between buildings, as well as data management automations for converting CAD and BIM files into GIS using ArcGIS Pro. Take a look at Esri-based apps that are now 3D capable and incredibly lightweight and can operate across native devices, desktops, and web browsers for end users seamlessly. The technology exists in the Esri ArcGIS platform to create really effective digital representations of complex physical environments for better and faster 911 caller location. We believe that together, we can save more lives and help protect more property than ever before. So with that, we'll wrap it up and turn it back over to Mike at Esri. Mike, have any questions come in for Reinhard or me?
Yeah, thanks a lot, fellas. Really appreciate your effort. There are a couple of questions. Let me start off with you, Carl, since I have you there. We have a couple of people who are currently GeoComm PSAP mapping customers, and they'd like to know how they can turn on the free RapidSOS integration.
Sure, thank you, Mike. So that would just all be about contacting your GeoComm representative to see if you are on a correct version that supports that, and they'll get you squared away with any other information you need.
Great. Reinhard, there's a question regarding, I think that you need to answer. Who controls, owns, and oversees the RapidSOS Clearinghouse? And maybe you could just speak for a moment to the process of consuming all of that location data information and then how the clearinghouse then serves it out.
Yeah, no, thanks, Mike. That's a great question, and yeah, happy to explain a little bit about RapidSOS and the business model and who owns and governs the data. I think that those are some very important topics that we care deeply about, and it's not just us. Also, you can imagine that partner companies like Apple or Google care greatly about user privacy and data security and every aspect of that question. So a little bit about RapidSOS first. So we are a technology company that has the mission of building transformative technology that saves lives, and we see location as something that needs to be solved as soon as possible. We have great ambitions of making additional data and greater situational awareness available to public safety, and we are monetizing these additional data solutions. Companies that want to send us data that is being made available to public safety are paying RapidSOS to do so. Having said that, for location, we have a different approach. We believe that the location issue needs to be solved immediately, and it's a public safety crisis that needs to be resolved before any of the other topics can really take off. I spend a lot of time with 911 centers, and everybody tells me that location is the biggest issue. So we are giving location for free. We deploy it to as many 911 centers as possible, and we work with every possible partner to make sure that location technology can be made available to as many 911 centers as possible as soon as possible. We do not monetize the data itself. We do not use the data for any commercial purposes. In fact, we, technically and legally both are not able to do that. So we don't own the location data flowing through our platform. We do not have an ability to see it or use it or sell it. It is exclusively provided to the 911 center answering the 911 call. So that is something that companies like Apple and Google care greatly about, is that location is not stored somewhere and then used for any other purpose than providing emergency assistance. And that's something that we care greatly about as a company.
That's great. Thank you. Carl, I'm going to switch over to you for this particular question. I think is interesting, and the responsibility for this may fall more on those who provide the actual 911 data to the call centers and then the CAD solutions in particular. But the question is, are there options for texting 911 during emergency situations where a person may find it's unsafe to talk or they're unable to talk? And again, maybe you could just point to whether that would fall back on other industry experts or something that you could answer.
Sure. So that's been an active rollout across the country for the last few years, and certain parts of the country are fully enabled and able to take text to 911 messages. However, there are certain situations where it's going to a state agency and not to the actual PSAP, the local PSAP where they are. So I would say it's a complex issue in terms of where that coverage is per state and per area. So it's an excellent question, and I believe there's maybe a resource out there that shows the rollout that we can maybe provide afterwards, a map. It may be an independent map, but it may show the current status of the rollout of text to 911 across the country.
Yeah, if I may add to that, the map that you're referencing is actually available on the FCC website. It's a great tool to look up whether a 911 jurisdiction has adopted text to 911, and there's also, for the more technically inclined, there's also some data around how it was implemented, whether it's integrated with the call taking system or whether it's through a web application. But what we see in general with text to 911 deployment is that the location data that's coming from the wireless carriers is often even more challenged than for wireless calls, because of the way that text messages are handled, which is different from voice calls. Often the same phase 2 mechanisms are not available for texts, which makes it even harder, especially if you think about the fact that texting often involves situations in which a caller cannot easily articulate what's going on. So think of domestic violence situations or abductions. Those are cases in which the caller might not be able to type in the address or articulate it otherwise. So for that, it's even more important to have better location data. And we're happy to announced that the Android ELS solution that was announced earlier today supports text to 911 also. So that's a great development going forward.
Great. This comes from a friend of mine named Scott. I don't know exactly how to best position this, but Reinhardt, what about devices that are not Android or iOS that are GPS enabled? Is that data going to come into the clearinghouse, or will that be a future enhancement that you need to work on?
Yeah, we're happy to work with every vendor. So if there's a device that is not on iOS or Android, there's not that many phones out there that meet that description, but we're open and happy to work with anybody who wants to, because we believe this should be an ubiquitous service. So we're happy to engage in that conversation, and perhaps we've already talked to them. We just haven't been allowed to talk about it publicly. In general, I just want to reiterate the point that the clearinghouse provides supplemental location information. It does not replace or interfere with or in any way interact with the location that's being provided through the existing legacy system. So every device has to report its location subject to the FCC regulations, which I talked about earlier. It might not always be accurate. It might not always work the way you want it to, but that regulation, that obligation does not go away, and it is on the wireless carriers. So if you have a device that is not enabled with the clearinghouse, you at least still have the same location that you used to have for the last few years. So in no situation are you worse off. It's only the devices that are enabled, and that number is rapidly growing. For those, you will also receive a supplemental location. But we do not interfere or compete with the legacy mechanisms that are already in place.
Great. So just to clarify, Reinhardt, that unless one of those device companies has registered with you, you're not able to actually consume non-Android or non-iOS 12 devices location information unless that company first reaches out and you guys create a partnership.
That is correct. And we're very happy with our partnership with both Apple and Google. Obviously, those are the two biggest ones, the two most important ones in this marketplace. So that's the obvious place to start and build out the platform.
Yeah, we would certainly hope that all others take advantage of this great service. Let me just finish with this last question, which I thought was kind of interesting, but maybe just speaks to the mechanics of how you're getting the information, maybe in a very concise way, clarified, Reinhardt. The question is, how do the devices know the IP address of the clearinghouse to send the data to? And I assume that's just something that you've worked out with Google and Apple to automatically deliver that data to your location.
Yes, as a general statement, that's configured as part of the operating system. The exact details of how that is being done, are somewhat confidential, but everything is, secured and encrypted and done in a robust manner. And what's important is that the public safety agencies do not need to worry about how the location is coming from the device and do not need to have a relationship with the device manufacturer. They just need to have the relationship with the NG911 Clearinghouse, and then it's going to be delivered in the same format, regardless of whether that is originally coming from Android or iOS or Uber for that matter, or any other partner that we may add in the future. It's very important to understand that everything comes in a standardized way that is using the NINA i3 standards for a location information server, which reduces the complexity and the cost on the PSAPs because there's no need to build additional interfaces for every new data source that comes online.
Great, thank you. One final question, and there are a number of questions that we just do not have time to get to, but I'll forward these on to the presenters today, and we'll answer those internally that are specific to GIS. does GeoComm and RapidSOS have any integrated mapping available in the ArcGIS online environment today? And if you could just speak to that. And of course, I love ending on that because I'm Esri.
Thank you, Mike. So the answer is GeoComm has prototyped an ArcGIS web app builder custom widget that works great with ArcGIS Enterprise and ArcGIS Online organizations and web maps. So long story short, stay tuned for more news from GeoComm on this topic in the near future. And I'll leave it at that.
Great, thank you. It's always good to have a little bit of a teaser. We're excited about what the future holds with this relationship and what's being developed. So thank you to both of you. In closing, let me just remind everyone that there is special pricing for the public safety audience, and just reach out to us if you'd like to get some idea on how you can take advantage of that nice pricing that's been made available. Finally, please just kind of keep in tune. We will be back again in November with another webinar. And if you're going to be at IACP, please stop by the booth. IACP is in Orlando this year, the International Chiefs Conference, and stop by the booth. Also visit with us in the FirstNet booth and see what's happening for those who have questions about how Esri works on the FirstNet network. Again, thank you to our presenters. Thank you to each of you for taking time to join us today, and we look forward to speaking with you again. Thanks.